In this question, we're being given a function here with respect to sine. So it's a sinusoidal, and we just need to find the value of h at pi on 2, aka this is 90 degrees. Okay, now we have a calculator. How good. So all we can do is first clear all the previous work for part A, and then we just write it in 10 plus 3 times pi. Let's bring up the keyboard, grab sine, and then have it as, we can put t in here if we want to, but sometimes that's a little bit hard to find if you don't have it along the keyboard here. So just use x for now. Make your life a lot easier. So here we go, we've got this thing, but now what we want to do is substitute when our value is equal to pi on 2, and also double check that we're in radians here so that you're not going to get weird results. So cycle through, click to radians. Now I'm going to use a little shortcut here. You don't have to. I'm just going to say when x is equal to, and I'm going to grab that pi on 2. So given that x is equal to pi on 2, or you can just put it straight in here. Both work. And the given that symbol, that can be found in Math 3 here, and it's kind of like the same as probability. So putting it through, we can just say for part A here that h, okay, of pi on 2 is equal to 11.5, and we just say use calc. Okay, that's that portion done. Now let's move on to part B. Okay, we're going to find t, all right, such that h is greater than or equal to 11, and for this domain here. So let's let's just plot this, okay? I'm going to plot it here, and it'll make life a lot easier. So let's go to our menu, go to graph and tabs. Again, I'll remove all the previous work, and again, I'm going to plot that plus 3 sine x divided by 3. And so I can plot this one, okay, but I've also got to zoom in on a particular area here. Okay, so we want to have this particular area from 0 to 3 times by pi. And then I'm not sure what our value is. Our value is going to be, so we can say it's like, I'll just say like, it won't be less than 5, but I'll put it in there regardless, so we can have a nice big thing here. Okay, so this is basically our value here. Now, we need to figure out when h is greater than 11. And if we plot that, we can kind of see that there's 2 points here. So you can either use it this graphical approach by going g-sol or and then intersections. So we've got 2 points here, that one, an x is equal to 1 point something or other. And then if I use this key, I go to another. So you can like bounce between them here. So that just gives a good graphical sense about what's going on. But because it's 1 mark, you can either draw this and then use the decimals here, but I would prefer to use main. So I'm going to go across over here, and I'm going to go to my main function. And for this one, that is greater than, what was it? Let me double check that, sorry. It was between 0 and t and 3 pi, okay? And h has to be greater than or equal to 11. So we can figure this out. If we grab our calculator out again, we got the previous plot here, and so I can either like plot it as so, and say plot using calc. And then use gsolve. And the original question here was asking us find t. So t is therefore between, all right, it's therefore between analysis gsolve intersection 1.0195. I think I can just squish it in there. And then moving along to the next one, we have it as 8.405. Okay, there we go. So that's one way, but using the main function, we can grab this value here. Okay, and we're going to say, given that x is between, where is it? Between these values, 3 pi and 0. Okay, and we want to solve, this one here. So we've got like a lower and upper bound for the values of x, so I might put that in there. I'm going to say instead, all of this has to be greater than or equal to 11. And we'll see if this works. Otherwise, we'll just stick with the graphical approach. And then we'll use the bounds of the numerical approach here. So solve between 0 and 3 pi. And it gives us something horrible. So let's just stick with the graphical approach. That'll make life a bit easier here. Cool. So there we have it. We've got the two values there, just using the graphical approach, and just ignore my attempts at using the Classpad here in the main function. So let's go across and find part C here. And this is just finding the derivative. So this would be super easy with the main function of our calculator. So bring it down here, and we go interactive calculation diff, and we're just going to find it here. Let's use standard so that we get a nice function. So what we can say is that's our value there, but if you notice there was another option that we could use. So instead of having to do 2 steps, we can say interactive calculation diff, and it says differentiate at value, and the value is going to be 2 and pi. Okay, and so now it's found a differentiation at that point. So we can just write what we used with the calculator. So say use calc, and then just write out what function we're using. So we're using this diff function, and we can say the value of h, x, and the first order at 2 pi. Okay, and that is equal to h tick to say that it's been differentiated. So there's 2 ways of writing that. You can either write it like this one or with the h tick, and you say that that at 2 pi is equal to minus 1/2. Okay, so the next step is finding it at this other point here. So you don't really need to know how it works to the same extent as if you were doing it by hand. But what we're going to do here is go interactive calculation diff, and we're going to go the second order just to show you what it looks like. And so this has given us the second order differentiation, right? But we wanted to find it at this value. So we can say use calc, and we can say h tick tick of t, that is all equal to, right? And we can grab that value there, that 1/3 on sine, and then t, don't forget to write t instead of x, and then we can say therefore h tick tick of pi is equal to, and then we can just substitute it in. So you can either grab it out like that, or we can grab this whole thing and say interactive calculation diff, differentiate at value. We're going to the second order, and we're going to find the value at pi. And then that is equal to minus 3 and 6. Okay, and you can say use calc. Now you can, if you want to, all right, you can, like it's 2 steps here, so there's 2 marks, so that's why I'm assuming there'd be 1 mark for writing out what the second derivative is, and then the second mark would be the actual value itself that you're substituting in. Otherwise, I would have said, just do this from the start and write it out, and then say to the marker, just use calc. But because of the 2 mark allocation, it's better to show 2 steps of working, right? But you can just write out what you're going to use, and that's the diff 10 plus 3 sine, and just remember to use t instead of x. Really common mistake is we're swapping between them, and then say x, the second order of differential, and this is the value that we're substituting in. Okay, so that is this value here. Perfect. All right. That will get you all the marks you need for this particular type of question in your exam. Now, there are so many more types of questions like this on my website that you can find. They've all got fully worked solutions, they've all got videos. Find it in the description below. And if you have any questions, reach out because I would love to help. So leave a comment or message me. See how I can help you get the best marks possible for your exams.